All right. I think let's just kick it off. Um, so today Evan and I, we're gonna have a bit of a sort of a background knowledge and sharing how we sort of understand EPD, what is EPD, and how we use EPDs to compare with different products and materials. Um, I'll go with the first quick introduction of ourselves. We're a AI solution specialist with a mission to measure, to basically demystifying, measuring, and accessing carbon. We're currently operating the largest digital EPD database in Australia with over 16,000 products listed. And leveraging on the data point, we've developed a agentic AI model that automates the carbon assessment process for building and infrastructure projects. All right, so today we're going to go through a few things and hope after today's session, everyone will have a better understanding of what is EPD. So we're going to walk you guys through what is actually EPD and how to read EPD correctly, because this is a super technical document. It's not a straightforward thing at all. And then using EPD to compare across different products, and then how to use EPDs in your design or policy or procurement process. Okay, so before we dive into the EPD, I want to sort of step you guys through what is embodied carbon and operational carbon, because this is a hot topic recently. And while we focus so much on embodied carbon, if we look at the chart on the left-hand side, at this moment, we're probably sitting around 20%, 20 to 30% embodied carbon compared to operational carbon. But with the renewable energy and grids are getting cleaner, the operational carbon would drop to below 20% by 2050, and majority of buildings' carbon emission will come from embodied carbon. So we'll have to tackle that. So what is embodied carbon? This is the greenhouse gas emission that related to the material itself. So it's basically the carbon emission from manufacturing this material to transport to site and install it on the building, and also operate it through this whole life cycle. So this is a bit background of embodied and operational carbon. And now that's why we focus on EPDs, because it is the third-party verified sort of like a certification that allows people to measure across building materials carbon emission. And one metaphor I always like to use to describe EPD is like a nutrient label. Basically, tell you what are the environmental impacts across these materials, and also give you a bit of sort of holistic understanding of not just on carbon, but on the other sort of water, the eutrophication. There's a lot of environmental impact indicators included, so provide you a holistic understanding. APDs are based on life cycle analysis. So to do APD, you need to conduct a whole LCA, and then sort of get the result from it, get verified, and then get published. So to emphasize the standard, the EPDs, there's different types of EPDs on the market. But to make sure you're using the right EPD, there's some standards you have to check before you use it. And in Australia and New Zealand, we follow this ISO 14025 plus in 15804, this combination. So basically, for any EPDs not following this standard, they're not comparable. And this is like more like a to use wisely combination standard across the world, covers EU, China, Japan, and our region. And the other standard we follow is ISO 21930. This is more like the US North American pathway, but just be careful when you using EPDs. If the EPD follow this ISO 930, it cannot be compared across with the other, the Australian or the EU one.
And probably just on that, Jason, as well, just to
Yeah.
simplify that first standard, the ISO standards, that's the ISO standard for environmental labels and declaration, and then the EN standards, like the European standard as well for environmental product declarations as well. So, just to kind of provide further context here.
Yeah. All right. And then how the EPD look like in Australia, this is a bit of a summarize over the past few years. From this bar chart, we can see it just surges crazily for the past 2 years. You can see in 2023, we have less than 150 EPDs published in that year. And just a year after, we have 1,200 published. That's almost like 9 times. And this year, we already got over 2,000 published. I think by the conversation we have with EPD Australasia, there'll be over 1,000 more coming by the end of this year. So it will be over 3,000 EPD published by the end of the year. And this pie chart also shows the distribution of the EPDs. Of course, concrete is the hot topic, and this is the most carbon intensive materials for the building and civil projects. And there's over 40%, almost like 50% of the concrete products, and that's in situ. And we also have like almost 30% of precast concrete being published. And following, there's plastics and the steel, paints, all the others are catching up. Previously, there's predominantly just concrete products, and now from this year, we're seeing more and more manufacturers are providing EPDs. And this is a bit of information of how EPDs are made. This is EPD production. It's a pretty lengthy and complicated process. So firstly, to start the journey, you need to select a PCR, which is the product category rules. Different material will have different PCRs, and also in different region, the PCR will vary. To identify what material is it, what sort of location or geographic sort of presence your product will be using. This is the first step, basically understand the PCRs. And then after it, you'll need to collect the manufacturer's primary data, which is the plant data, the energy data, and also use a combination of background data to build the life cycle analysis model. And once the full LCA has been finished, you need to push this to the verification process, typically going through the review with a third-party verifier, and they'll going back and forth with questions until they're happy with everything. And then you move to the registration process. It's typically with a program operator. In Australia, we have EPD Australasia, we have Green Tech. So literally after you do the verification, this will need to flow into the program operator to register EPD and then publish your EPD. And then where to find the EPDs. So there are two sort of methodology to do that. Like the first one is going through the program operator's website. In Australia, we have EPD Australasia and Green Tech. So basically what you could do is just type their name in the Google search and jump into their website and search EPDs over there. And you also have like EPD International, that's more like a global sort of the coverage. And IPU, that's more like European, German coverage. The other way is to use digital EPD database, like ourselves. We focus mainly on ANZ region. And EC3, they're heavily US focused. So this is like with digital EPD data, you'll be able to search through data in a more sort of like a faster and easier way rather than going through the PDFs. Okay, so this is more like the background knowledge of the life cycle analysis, and also understand what is embodied carbon and why we focus on certain stages. So over here we can see this dust circle that represents the embodied carbon from A, B, C stages. The A stage is what we call upfront carbon. That includes the product stage, which means the raw material supply, transport to the manufacturing site, and then the whole manufacturing process. And that's A1 to A3. And then we usually use cradle to gate to describe this process or coverage. And then after the product being manufactured, we need to transport that to site. So that's A4. And A5, that's basically putting the material or install the material into the project you're doing, this A5. And we refer to this whole thing as upfront carbon or cradle to practical completion. And then after the building or the project has been completed, we move to the operational phase or in use stage. That's B1 to B5. That's related to how the building or material being used, how many times it need to be repaired or replaced during this whole life cycle of this building. And then we move to the end of life stage, basically how we going to dispose it, how we're going to take care of the building after demolition. So this is what we call cradle to grave. And beside this, there's also D stages, basically after the material being removed from the building, how we gonna sort of dealing with the materials. Are we going to recycle it, reuse it, or dispose it? No, there's other ways. That's basically D stages, and that's what we call cradle to cradle.
And I was going to add to that, I guess. So from a concrete perspective, it was required to do life cycles A1 to A3 up until about March last year. That was like the minimum compulsory one. From the recent standard change now, all concrete EPDs, new ones, have to do A1 to A5, the end of life, but the C stages and also the D stages as well. So, but after you get to A3, like A3 is like until it rolls out the gate of our concrete plant. The transportation, the installation on site, that's like a kind of a typical scenario, I guess, as well. We have the delivery distances to our customer sites. We use the data for that as well. But then the installation on site, we run a hypothetical scenario for a typical scenario, and same as like end of life and the circularity component as well.
Yeah, that's right. Like normally A4, A5, and those are all scenario based and based on assumptions. So when reading EPD, it's really important to make sure you capture those assumptions or scenarios. And then you understand this is not a static figure. Like when you do calculations yourself, you need to actually adjust this figure based on your project location.
I think it's like very beneficial, like kind of have that as well, like because I mean for concrete it's like fairly inert through the use phase, and there's not much like repair to it as well. But at the end of life, what does it take to kind of like return it to a reusable state as well? And I guess for different types of materials, like say like paint or something, go building life, you might have to repaint the walls like 4 or 5 times as well. So when you want to look at comparable like to a whole building life cycle assessment, you want to go, well, how many times I have to paint the wall with this product? But okay, there's another product which will last twice as long as well, but maybe slightly higher impact. So you can start having a look at those different like scenarios, like is A better than B if like I don't have to paint it as much. So you can look at the total life cycle assessment as well. So I think it's really good that EPDs declare all those various stages so you can look at a comparison of it as well. So I mean asphalt's another one as well. Like in use, like some might have higher emissions, but it might have a longer life or and vice versa as well.
Yeah, exactly. We do have a case previously for a infrastructure projects. Like when we did the upfront carbon analysis, the paint is almost negligible because it's like less than 1%. We'll end up doing this full life cycle analysis, and then paint percentage had jumped up all the way up to 18%. And we were curious what was happening over there, and then we started understanding why, and the paint service life is only 2 years. So over 100 years life cycle, you have to repaint it 50 times. To compare with just upfront carbon, this whole life cycle just times 50 of that less than 1% figure. So it just went up quite a bit. So when doing decisions, it's definitely important to consider this in use stage, and just not just focus on upfront carbon. Yeah, Greg, sorry, I just saw just put your hand up.
Yeah, no worries. That's just a quick question on. So, like, obviously, it was A1 to A3 up until you say March this year. Are there any sort of repercussions that somebody trying to read an EPD or might have in terms of if something's been calculated before that, like in terms of going back? So, say you've looked at this and you've done calculations in this time last year or whatever. What's the or like last 2 years ago or whatever, are people generally going back in, and is it like are you updating previously published EPDs with A4 and 5, or because otherwise it's hard to sort of compare 2 years ago to now. I'm not sure what the percentage of emissions from A4 and A5 would be, probably not that high, but yeah, is there any sort of way to look at
good question?
Yeah,
I think
yeah,
you go first.
Okay. All right. So typically A4, A5, they're not mandatory modules. So a lot of EPDs were not included. And in terms of comparison, like you need to keep the versioning really clear. Like there's a lot of EPDs over there, and you probably open up an EPD that's version 4, version 5 already. So to do the comparison, you need to actually trace back all the way to version 1, understand what are the assumptions or scenarios used over there, and compare with the version you're currently using. But again, for a lot of EPDs, this whole EPD production thing has been only been around for like if you look at that thing, that chart, it's been like the past 3 years. And the validation period for EPD is typically 5 years. So a lot of those EPDs are still under version 1. If you ask the question, how can we compare with the previous ones? I don't think I'll have the answer for you, because that's the first reference point we can actually find on the market.
Yeah, good point. So I think EPD is valid up to 5 years, but if EPD is available on EPD Australasia and international, like it has to be valid at all times. So if it's still there, it means it's valid. So as like a user, we have to keep reviewing it and make sure that that number is still representative of like the published one. So the actual kind of matches it no more than the 10% variation as well. So if it's up, it has to be valid. You can notice with the EPDs as well, like you'll have on the front plus A1 or plus A2 is like the new standard. I guess standards are constantly kind of changing and updating. So to be able to register an EPD now has to comply with all the latest standards. But I guess if it was registered 3 years ago, it only had to comply with the standards at the time. But so you don't have to update an old one when a new standard comes out, but it does have to stay valid at all times as well. An easy way to tell the difference between the EPDs, when you go into it, you'll notice that like it used to be global warming potential only, and then in the new plus A2, they also split out there's the additional parameters, which we'll see shortly as well, and that's also around about the same time as when they added in the additional life cycle phases. But typically, like for a customer, like when someone uses it for like say a Green Star or infrastructure project as well, they take the A1 to A3. That's like from the gate at our concrete plant, and then they'll model their own transport to the site, their own installation of what they actually kind of did, and then they might use our end of life scenario if they like want to run a scenario. I think Mitch has got his hand up as well, Jason.
Yeah, thanks. Just jumping in. Just to check, when I was reading an EPD, it was a Boral for their low carbon concrete. When you mentioned like location of the project, it was like Sydney region and like kind of. So when you're talking location, that is like the regional location, not like a very specific, our council.
Yeah,
like how
it will be different.
Yeah, I guess it depends on the EPD, but just to clarify, it's talking more like the EPD had the regional figures, and anything more granular, I guess, can help. But it's
that's it's for when we do EPDs, because we got so many like mixes for concrete, and the variation of them change between different regions. We've been we do them in regions as well, or initially. So, but like with like the Southeast Queensland. So that's for all the plants that we operate in Southeast Queensland, and then that's like the representative number for the region, depending on how they do it for that particular mix. Something what we've been working on was like through our MECLA working group is actually putting out some guidance to actually say, hey, we should really say every single, like list the actual plant. So if it's like Sydney region, what does that mean? Like where are the concrete plants located in the Sydney region? Like rather than people having to go to like the Boral website and trying to find it and like, okay, I can see it's in Randwick, this one, that one, that we're trying to put out guidance, like specifically say every single plant that are in, like list them out, because that in the future, it'd be really cool to like geocache some of these things in. Like I see in the future, you'll see the EPD data on like a map. So you'd be like, oh, my project's here in Randwick. What are the plants around it? You'd be actually able to see the specific products and their performance for all the different plants. You'd be able to see them on a map, I envision. But yeah, at the moment, I think we've been guilty of it as well. And some of our old ones like Holcim's EPD for Sydney region. And we haven't specifically listed the plants that fall into our region for Sydney.
Yeah. Also, just on that question, Mitch, like there's different types of EPDs. Like there's like Boral ones. If you look at the Boral's or EPDs, there won't be A4 involved because this is like based on a really generic region. But there'll also be EPDs like you actually can find the specific scenarios of where the plants are and where's the project location. Say, for example, if you go to a Hansen's EPD, you'll be able to find, okay, where's the plant and where's the project site, what's the total travel distance, and you'll be able to calculate based on your own project, just don't use that figure straight away because this is based on scenario, but you can actually figure out what's the CO2 per kilometer and apply that to your project. But it also, again, this depends on what EPDs, how EPDs are made, and there's different quality and there's different sort of standard, and all those information are compulsory. So it's really up to the suppliers how they do their EPD.
Cool. Thanks for that.
All right. Oh, no worries. And then this is something we'll literally just talk about A4, A5, and the CD. So I'll skip this one and jump into this basically understanding what is EPD and what the information is included. So in the EPD, there are the 5 key sections. There's the cover page, the intro and scope, the methodology being used, and the result table for you to find those indicators and additional information. So some key information that for EPDs you can find is, firstly, we open the EPD, it's going to be the cover page. And over here, you'll be able to see what's the EPD name. And this is like usually have the particular product name. And for example, this one, you have the concrete mix code over here as well. And who's the program operator. And you see this is EPD International with EPD Australasia, validation period on the other side. All right, this is valid from May 2025 all the way to May 2030. Who's the EPD owner? This is typically in the next page. You can see over here on the Evans, the EPD owner, and who's the EP verified, who verified it, what are the PCRs, and what sort of standard it complies. All those information typically you'll be able to find in the first 2 pages. And then next, that's a really important thing for you to look at as well. That's the declare unit. This sort of gives you the baseline to compare different materials. So over here you can see the declare unit is 1 meter cube of the concrete, and also understand after that also understand what are the scope of the reporting. Some of those are A1 to A3 only, and whether this include A4, A5, C stages, or module D. So over here you can see this is cradle to gate A1 to A3 with options in module 5, A4, A5, C and D stages. And also you can find the product details on how product being made, what are the detailed components, what are the percentage of the detailed ingredients. That's something you can find in the EPD as well.
I think like the database is probably like not for an average user, but I think for some of the practitioners, it's really interesting. They can see like, okay, well, where's Holcim drawing the data from as well? What's our hierarchy? Mm-hmm. So we actually use EPDs ourselves for our EPDs. So our cement's covered by an EPD, and a lot of our admixtures are covered as well. So we use EPD data first as well, and then if we don't have that, we'll use Australian life cycle data, and then Eco Event, which is the global life cycle data as well. So really interesting when you're looking at it. If you're at that kind of level, it's like, okay, well, what are they using? So it's like some transparency and like what's the modeling, what's the assumptions, how they've gone through the process as well. So there's that level of detail in there for you want to kind of transact it as well. One for the declared units, I think that's a really important thing as well. In some EPDs, it's always in a little different location, but for concrete, it's very simple. Like all of them will be per cubic meter of concrete, but when you go into like steel, like some use a declared unit of kilos and some use tons, so or linear meters as well for someone. So it's really important to try and find that declared unit. So then when you're looking at the numbers, you know what you're looking at.
Yeah. All right. Okay, let's move forward. And this is more like the indicators you'll see from this the EPD. The most important one, I think the most practical one for us to use is the GWP suite that come with the GWP total, GWP fossil, GWP organic, and GWP LULUC. So mostly you'll need to use the GWP total, and that's basically tells you the carbon emission equivalent of this products. And then apart from that, you'll be able to find all the other indicators like acidification, purification, and resource use like the water, the energy use, and also waste categories. This typically can find when going through EPD. Most EPDs they're in sort of like different format. Like when I sort of look into EPDs, this is the first section that goes into horizontal. Previously, it was like all vertical. That applies to, say, 70% of the cases for you to quickly locate the indicators. Over here, yeah, I want to quickly touch base on biogenic carbon and timber EPDs. People may get confused why when I look at the timber EPDs and then the GW total becomes a negative figure. It was because it includes this biogenic carbon. Basically, that refers to the carbon sequestration process that basically taking the CO2 from the air and then storing in the timber itself. That's why it sort of offset a little bit of carbon. And when you look at the detailed GWT breakdown, you'll be able to find the GWT biogenic, that's a negative figure. And when you do assessment, we do recommend to use GWP fossil rather than GWP total for timber products, especially for the current rating scheme neighbors and Green Star. The exclude the sequestration process, which means for timber product, it cannot be a negative figure. It cannot be offsetted.
And this,
right.
and I was just going to say that's probably one of the changes that really happened was that plus O2 standard. So prior to that, they had just global warming potential all lumped up as well. So if you see one where it just only has one number, that's under the old standard. And then under the new standard, they're like, we've got to split this out because it's like, timber's negative 700 kilos. Some that's come from the biogenic, but it's actually got fossil emissions. You couldn't actually understand or quantify that before. So it might be like, negative 700 was the biogenic absorption of that, assuming that it's going to get replanted, but then maybe 120 kilos for the fossil emissions as well. So now they kind of split that out, and particularly under new standards like neighbours, I think, and Green Star, they only use the fossil emissions. That the biogenic goes under a separate credit.
Yeah, that's right. Like when you do typically the upfront carbon analysis, for timber product, it's going to be the GWP fossil figure. It cannot be a sort of a negative figure. All right. Okay. Then how to use the EPD? As Evan mentioned, the functional or declared unit, this is super important. So first thing you need to do is to confirm what's the functional unit or declared unit, and then go into the scope. What are the coverage and scope? Is your project only going to do upfront carbon, which is A1 to A5, or do life cycle analysis, which is A2D? And then check the EPD's validity period and also the geographic service, the scope. Like understand whether this EPD is relevant to my project. Like if you're looking at concrete products, it has to be really local. Like you cannot really go online and find a European concrete EPD and use it. That doesn't serve the purpose. And then after you locate the EPD and then go into it, find the GWP and other key indicators for your assessment, then compare this figure with the industry benchmark data. So for example, neighbors or also the EPIC database. Then once you've done that, you can actually use the result to choose a low carbon or demonstrate reduction for your projects. I just want to touch base on this comparison of declared unit and functional unit Evan mentioned previously. Those two are actually different. If you go into EPD, sometimes you'll find both. Sometimes you'll find only declared unit. Declared unit, that means for this reporting, I use this base unit to report. But functional unit, that's basically on the performance base when you actually assess this material, or like the common sense is to use, so for example, steel cladding is to use meter square to assess it rather than the weight. So you'll be able to find a lot of sort of discrepancies between those two. Sometimes you'll find, okay, for steel products in the EPD, it's measured in weight. But in all your sort of quantitative assessment that's being in meter square, that you need to convert the unit before you apply the EPD data. So that's super important and bear in mind. And this could cause a lot of so a huge measurement difference. Like we've experienced a lot of things like this before. Some clients who don't aware, okay, those two are different, and just apply the EPD unit and end up having a crazy figure. And this is more like on the data side, and when you actually look into the EPDs, it's also important to understand how the data are allocated, what are the cut rules for the data input, so what are the exclusions, and also for the data quality, understand what's the percentage of the primary data, which is the actual plant data being used, and what's the percentage of background databases. We do see a few EPDs that use pretty much all background databases. That doesn't give a good result, and also that doesn't really serve as their product, because they just use the industry generic database. A few checks when you use EPD, they're all verified, but they're not perfect. There could be mistakes. The first thing you need to do is check whether they're valid and whether they're published through a program operator. There's a lot of EPDs on the market. Some are self-declared, some are just the LCA result. To make sure the EPD is valid, it has to be published through a program operator. So this is the first step before you use this EPD, whether this EPD is valid or not. And the second is to understand whether this EPD is consistent across the measurement. Sometimes we do see examples in the product description, it describes one thing, and the actual EPD indicator table, it talks the other thing. So this is a big no-no. You need to make sure those are all aligned. And the third one's the unit, like we discussed before, like we need to ensure the unit matches your use. And then it could be some EPDs with incorrect figures. That happens quite a bit. And if you see any crazy low figures without sort of a substantiation of how they actually get this low sort of emission, you need to put a big question mark over there. And then when you use EPD, there's a few languages we can use to require it. For console's purpose, always can require suppliers to provide a EPD that has to be compliant with those two standards we just mentioned, set a scope, and then set a preference on the product GWT performance, and also request some information if there's any plan specific information to get some evidence. Set those terms upfront. Some tactics we can use for design or for specification. One thing we can do is to set a upfront carbon budget for different material types. And then basically when doing the procurement or doing the design, we'll have a target over there. And then always prefer the materials with a lower carbon emission. That's basically proven by the EPDs. So for example, concrete with low SCM percentage, or for aluminum with high recycled content. And then after you've done that, you can use EPD-based baselines to demonstrate a reduction target. So we can say, all right, we want to demonstrate 20% reduction comparing to what database. It had to be really specific because all the databases are different. And then set this target. And also you need to record all the assumptions and modules that while doing this analysis, you sort of put over there that gives the clarification of how you assess this embodied carbon. All right, so this is more like a quantification process of how you calculate the carbon emissions by using EPDs. So this process starts from gathering the quantities, usually come from the bill of quantities or some beam data or cost plans. And once you have the quantity, what we need to do is actually identify each line item a material type. It could be, a composite line item saying this is the reinforcement slab, and you need to break that down into concrete and steel. And then after you sort of map each line item with a material type, then choose the EPDs to map the exact sort of product with the quantity takeoff, do unit conversions, calculate the totals, and then run analysis on A4, A5, then generate the final output. There's some common mistakes would usually happen in this process. We talked about quite a few of those before. Just want to reemphasize it. The first one, you need to make sure the unit are different. You can't compare a material with different unit and then use the coefficient to calculate. And the other one is to align the scope, whether it's A1 to A3, A1 to A5, or A to D. And for timber products, make sure you're using GWP fossil, not GWP total. And there's EPDs for industry average or plant specific, and you need to go into the EPD and find whether they're, falls what bracket it falls into, and then actually document all those information so they're actually different. And then region. So when use the EPD, understand what the EPD's geographic scope, and that's really important. And then choose the materials that close or applicable to your region. We've talked about A4, A5 before, but I just want to share a bit more based on my experience, how we manage A4, A5. Typically, when we start a project, we need to set a project location over there, and then we put a radius for certain materials. For example, for concrete, we want to put a radius of 100K, so we're going to source materials within this 100K radius. So that's an important step to maintain or control the A4 under a certain threshold. A4, A5 installation and construction, that'll vary from project to project, but there's something we can standardize. For example, we can standardize the waste percentage by material type. Rather than having different consultant making different assumptions, you can have a standardized percentage or a list over there, so they can just follow. And for A4, A5, people always think this is a small portion, but it really depends on projects. We do have some civil projects that's really heavy on A4, A5. It's actually almost equivalent to A1 to A3. So just be careful, not excluding it or overlook it. It depends on different project types. For data, we do recommend keep record of everything, save the EPDs, keep the EPD mapping, making it like a log or like a spreadsheet. You just keep everything on record. Make sure all the assumptions are documented, and also track if EPD is expired. There will be cases like his project will run, multiple years at the beginning of this design process. Version 1 is available, and then stage 1 we use the version 1. This stage 2, this project, the EPD has been updated, and then in that case, track the version used. You cannot just replace everything with version 2. Use version 1 as per the project, and then version 2 probably that's for the next phase, and then use version 2 to track all the versions and to match the exact material being installed on site. There's a few sort of material shortcuts like we found throughout the years. The first one's always concrete. Like when we use concrete, prefer a high supplementary cementitious materials with SDM percentage. Basically, replace the cement with slags, and that will reduce the your GWP total substantially. And for steel, prefer electric arc furnace. Asphalt, prefer high reclaimed asphalt pavement content. And for timber, insist on this one A to C scope. In C scope, you'll find some interesting insight over there, and definitely review the biogenic notes. For aluminium, use the high recycled content and electric mix. So all those will bring you to a low carbon sort of the target and reduce your carbon footprint. And that's when you do material selection. Though here, there's a quick example of how we use EPDs to do concrete comparison. I'll walk you guys through this, and we can do a quick exercise of reading and using EPDs to do to get some quick analysis for some quantities. So the goal for this one is to compare two 32 MPa concrete mixes. And then the first thing you need to do is make sure the the functional or declared unit are the same. And then then you need to make sure, what are the scope of the assessment? It is A1 to A3 or A to D or A to C. Then you can confirm the details of what are the SCM percentage, what are the location, and what are the performance details. Sometimes EPDs will include performance application data as well. And then you can use the figure GDB total you found in the indicator table to calculate, each mix, the carbon footprint at A4 if necessary, and then you can have the result ready. All right. Over here, I have a small exercise we can do as a group. So this is a description. So typically you'll have a quantity takeoff from a QS or from a builder, and then you can actually review what's included in this item and calculate based on the EPDs. So this example is there's 200 meter cube of 40 MPa reinforcement concrete columns with a 200 kg reinforcement ratio. Then we calculate both the baseline and actual project upfront carbon emission. So the first one is the 40 MPa concrete, and the second one is reinforcing steel. And this is the coefficient you can use for the baseline. And for project EPD, what I'll do is I'll send the EPDs in the group, and you need to go into the group and check the EPD and find the figure yourself. And once you've done it, you can populate the answer in the chat.
This is tough. We've got to go find. Just conscious of time as well, Jason.
Yeah.
I was just noticing on the chat, there's a couple of people said they got to kind of drop off now or something. But oh, you've got the link.
Probably just 1 minute, quick exercise, and you can finish. I'll jump straight into the answers.
Let me give it. Do you want to pop the link in for the steel one as well into the chat then?
Yeah, I think those two are all in.
Best bar, yeah.
Yeah.
So yeah, I think we've only got the concrete link in the chat at the moment, Jason.
Is it? Okay.
Yeah.
I think perhaps just wary of time. Maybe if you just cheat sheet it for us, actually.
Yeah, I'll share the.
Might need half an
EPD
hour for
as
this
well.
one.
Yeah. Also, I'm stuck and I don't want to look stupid. So.
All right. It's pretty straightforward to calculate it. Just need to find the quantity of those two, which is 200 meter cube, and use the generic database over here to calculate your baseline. And that's basically how you calculate your baseline analysis. And that's your reference case. And for actual project, the product upfront carbon, you need to do is to go into this EPD, and if I reshare my screen, I'll actually take you guys through this EPD.
At least with this worked example, it's a bit easier because I think concrete EPDs now can only have one product in them as well. So it's super easy to find it. So this EPD has that mixed code on it. So you can search for that mixed code. You can find this EPD and then you just roll down to the table. And
that's right. So it's typically the first horizontal table over here. And in the first indicator, you'll be able to find the GWP total. This one, it's usually the first one, and A1 to A3. So this is A5. You just take this figure and multiply it by the quantity, and there you go. You'll have the concrete one calculated. And same thing for the steel one. Going to the table, the presentation is a little bit different. You have to get sort of used to it because every suppliers will have their own presentation. And same thing, this is the first line item over here, and find A1 to A3, and then calculate it. For this one, the tricky bit is in the coefficient is the unit. You need to convert this kg to ton just to make sure they're all aligned. Otherwise, you'll have 1,000, but you'll be up by 1,000. So yeah, and then after you've done that, you can do a comparison. Okay, by using this concrete, give me 39% reduction. By using this steel, give me 50% reduction based on compared to baseline. Yeah, hope this is not too complicated. But anyway, yeah, you can go into those two EPDs and read through the details, and always come back if you have any questions. All right, conscious of the time, we do have, you can close it out. When you do EPDs, those are really important information for you to tick the box. And, for key takeaways, it's a summary. What are the EPDs and how you can EPDs for comparison, different life cycle stages, and also target A1 to A3 with A4 to start with your carbon reduction journey. All right, I'll stop sharing, and then and we can take any questions.
Yeah, amazing. Thank you so much, both of you, for taking time out of your schedules. That was super useful. For me, I was just sitting here thinking, I was quite deep into the EPD world in like 2021, 2022, but the whole landscape has changed.